How are you? Welcome to this new class in which we're going to be doing an approach to the architecture part of the OMniLeads web application. As already, we were experimenting. The application is based on containers. That is to say, each component of OMniLeads is content inside a container worth the redundancy. Docker, in the case in which we have been working here in desktop environment. So, here in the same directory where we have the Docker compose file that we are using, I can do Docker compose, Docker and or half compose. PS is going to list the containers that are being orchestrated by my Docker compose file. If we dig into the file, we're going to see that each of the components is, let's say, one tab away from where the file starts from, the margin line. And here we have the web application. We have another group of another service called channels, which is the Django channels service for the asynchronous part of Django. We have a container where all the necessary crons are in there, which uses OMniLeads primarily to bring some things from SQL and put them in Redis, so that then the real-time views directly consume in Redis. Is a crucial component. Also from the OMniLeads stack, which essentially implements the fast AGI functionality of Asterisk. Here we have the Asterisk component, the ACD, the call distributor, and Nginx, Postgres, Redis, WebSockets, Minio, explaining what each of them is about. But, what I wanted to show is, as we have the Docker compose, the composition of our application using this YAML syntax. And, contrast it with this diagram, block diagram, which is about showing the relationship between the system users and OMniLeads. The browser, which is where users of the supervisor or administrator type enter, as well as the agents that answer calls. And we will see later the part of video call and web calls as well. But for now, I am going to stay with agents and supervisors. They always hit, or their request will go against the web server, which is Nginx. And Nginx, depending the path of the request, will redirect the same to the request to the web application part, Django, the synchronous part of the web application, the asynchronous part, which is driven by a component called Daphne, and is the asynchronous communication part between the browser and the application, which is a component based on Python, OMniLeads' own creation, which implements another aspect of the synchrony, Camilio, who is responsible for the WebRTC bridge, along with RTP engine for translating everything related to WebRTC, which is how the browser communicates with the application. 2. Traditional VoIP, therefore Asterisk, is not aware of the WebRTC world, since Kamali and RTP engine function as a gateway, as a bridge between the WebRTC world and the traditional VoIP world. Then we have the data storage part. On the one hand, we have Redis, which functions as a cache. Yes, Redis is a fundamental component of the application we will enter later in a more advanced architecture chapter. For now, it is a more introductory part. Redis is going to cache everything that has to do with the more real-time issue, where the application needs speed to read and write some things. Postgres will persist everything that is the configuration of the application, as well as everything that is the logs and registers, all the part of historical of calls, of agent sessions, of qualifications, of ratings, and so on, of agent, of qualifications. Everything that happened with the campaign is going to be persisted here in Postgres. And while Minio is a component that appears now in this new version, OMniLeads implements the technology of storage based on objects with an API S compatible in such a way that now the storage of files as recordings, as the SBs that are prepared that some views generate, are going to be contained. They are going to be persisted in this component. That is a storage technology, object-oriented storage technology, with all that implies. At some point, also, we will go deeper into this. But well, this, among other things, will contain the call recordings. We have a container, as we saw, that stores all the crons. Generally, the crons are queries, Postgres that end up entering as keys, values in Redis, so that later the supervision views can or react to the content that is being inserted. Here, the part of Fasagi with asterisk Anman, a dupla-where asterisk action that needs to be done, like knowing if a call needs to be recorded or not, or asking for information about a trunk, about a rote, is done through FastAge. And FastAge also interacts directly with Redis. So, well, this is a picture of the skeleton at the component level, an X-ray of the OMniLeads skeleton. And each of these components is going to correspond with declared at the level Docker Compose. It is also very important to get to know and being aware of the environment variables needed by each of these components. Each of these components to operate needs certain environment variables inherent to the component. For example, if FastAgi is connecting to Redis, well, it will need suddenly the host name to make connections to Redis. If asterisk has to save recordings in Minio in the storage object, then it will also need those parameters, isn't it? As well as not just the bucket name, the access key, the endpoint to save, send them, the requests to the storage object. And so each one of the components will have its own series of environment variables. If we look at Nginx, for example, and we know that Nginx is the component that is in charge of distributing the requests that arrive at the web level. And well, it is going to need the information of hostname, where to redirect the calls to Kamalio, to WebSocket, to Daphne. And for that reason, we have the hostname here of Django, of Daphne, of Kamalio, and of WebSocket. So successively, we will see how each of these components will have its environment variables necessary for the component to interact with the rest, making the application, the web application. Here we have another view of, well, as they distribute with a Docker Compose app-d, then we lift the stack that we are using is the Docker desktop stack with the PSTN emulator. So, well, what I wanted to leave reflected a little bit is this question of understand a little of what are these containers that we are seeing. And well, in later sections, we will enter a little more deeply in each one of them. I would like to see this issue that I could hear to each of these components, visit them at the level their identity within what is internet, within what is at the repository level, each of them Each of these components that we were visiting a little bit above has its corresponding repository where the source code and configuration code is. For example, ACD, as such, is the component, just as it says here, of asterisk that distributes the calls. We have the information of how to build it to have suddenly the own or customized images. And as for the deploy well, we directly refer to with the repository that we are seeing now that we have been working, which is the deploy tool. But well, here we are going to have the source code, the part of the scripts that make to this component of Python, the source code at the configuration level of asterisk dial plan, the same for all. If I suddenly introduce OML, that for us would be this component already materialized as a container, but at the level of the repository and source code. This component also contains the source code with the corresponding Camalio CFG. That models the behavior of Camalio according to what is expected for the application. And additionally, it also has instructions on how to build. For those who wish to create their own images, the same we will see for engines. For the web application as such, OMniLeads, the main display component where all the logic resides. Of what is the web application itself as such in Django is going to be here, or mini contact here. This repository, well, it's a little bit more information because it's like the neuralgic point here, one of the main ones. So while each of these containers that contain an OMniLeads component at the deploy level with Docker Compose are actually backed up in a repository with the source code, configuration, and instructions on how to do the building of each of the images that are then going to run through the Docker Compose that we're using that are going to materialize our application. Already, as I said, in later classes, we are going to spin a little finer, especially in the part of troubleshooting to understand, well, how all these components are interrelated. But in a first glimpse, I would like us to stay with this, with the topic of the Docker Composer that the images, here we have everything that are the images that actually come from the environment, invokes the images of each one of the components, launches them as container with its configuration, and they make and orchestrate so that all this makes sense, so that all this is functional.